Hello everyone, this video is about proving trigonometric identities. First strategy, start from one side and get to the other side. So you don't write both sides at once, just one of the sides. Let's start with the more complicated side. On the left is 1 plus 2x minus cos squared x over sin x plus 2 cos x, and then we can use the Pythagorean here because it's actually the same as if we just rearrange the order. 1 minus cos squared is actually sine squared, so we have sine squared x from here plus sine 2x. Well, sine 2x is actually 2 sine x cos x, the double angle sine, still divided by exactly the same. So let's just copy from here, and now we can factor out sine x from the top. So we have sine x plus 2 cos x which is exactly the same as the denominator, so they cancel out. And so we have proven that the left hand side is the same as the right hand side. Next strategy, if you have the angle, you can simplify or use a calculator. So using the compound angle cos minus sine and cos 30 degrees happens to be 1/2 root 3 over 2 cos x minus 1/2 sin x. So it's just simpler. From here you can maybe use the auxiliary angle method and so on. And don't forget we have this algebraic identity. So 1 minus sine squared is actually the same as like 1 squared minus sine x squared. So it's in the form of a squared minus b squared, which is equal to a plus ba minus b. So 1 plus sine, 1 minus sine, and here we can cancel out some things, and we have only 1 minus sine x. Simpler now. The last strategy, cos double angle form to eliminate the constant. So we have these two forms of cos 2 alpha. If we have this kind of expression on the left, 1 minus cos 2x, if you wanna somehow get rid of this 1 here, the constant, we can reuse the 1 minus 2 sine squared form, because when we open up the parentheses, we get 1 minus 1 plus 2 sine squared x. So we can cancel out the constant. We have only 2 sine squared x. Same thing here, we have minus 2. We can get rid of this using a positive 2, so we can get it from here. So we have 2 cos squared x minus 1, and after we multiply everything we get 4 cos squared x minus 2. Actually, it wouldn't work because we need to use plus, so let's use plus again. 1 minus 2 sine squared x, and we get 2 minus 4 sine squared x minus 2. We can cancel out 2. We have something simpler. This might help you solve or prove trigonometric identities. That's it. I'll see you again next time.